Welcome to Discover Daily by Perplexity, an AI-generated show on tech, science, and culture. I'm Alex.
And I'm Sienna. Today we're diving into Google DeepMind's new AI system, AlphaProteo, which is making significant strides in protein design for biological and health research. But first, let's look at what else is happening across education and science.
A recent study from Harvard University suggests that AI tutors could significantly boost student engagement in higher education. This research, which has not yet undergone peer review, compared the effectiveness of a custom-designed AI chatbot tutor against traditional active learning classroom settings in a college physics course. The study, conducted during the fall of 2023, involved 194 students. Researchers divided students into two groups, one using an AI tutor for introductory material and another participating in traditional in-class instruction. The AI tutor was powered by OpenAI's GPT-4, with the prompt then refined through iterative testing for the particular class. Key findings from this preliminary research indicate that students in the AI-tutored group showed learning gains approximately double those of students in the in-class group. Students also self-reported significantly higher levels of engagement and motivation when working with the AI tutor compared to traditional classroom instruction. The study's authors attribute the AI tutor's success to its ability to provide personalized feedback and allow students to self-pace their learning. However, they emphasize that AI tutors should complement, not replace, in-person instruction, particularly for developing higher-order thinking skills. Harvard is betting that this is more than just a novelty and is expanding the use of AI tutors in several large introductory courses. In another development, Stanford University researchers have discovered that tartrazine, a common food dye, also known as FD&C Yellow No. 5, can temporarily render the skin and tissues of living mice transparent. This non-invasive method allows visualization of internal structures without surgery or specialized imaging equipment. The transparency effect happens when researchers apply a water-based solution of the food dye to the skin. This changes how light moves through different parts of the tissue, making it scatter less and allowing researchers to see through it. The process allows researchers to observe internal structures such as blood vessels, organs, and muscle fibers at a micrometer level without invasive procedures. In experiments with mice, researchers applied the solution to the scalp and abdomen, revealing underlying structures within minutes. The process is fully reversible. Simply rinsing the skin with water restores its normal opacity. This technique could help non-invasive diagnostics by allowing doctors to visualize veins more easily for blood draws, enhance laser-based tattoo removal procedures, and aid in the early detection and treatment of cancers. However, applying the technique to humans presents significant challenges. Human skin is approximately 10 times thicker than mouse skin, requiring higher dye concentrations and potentially different delivery methods to achieve the same effect. Researchers still need to determine the appropriate dosage and application technique for human use, so future studies will focus on addressing the safety, efficacy, and potential delivery methods to make this technique viable for clinical applications. Now to Sienna for another medical advancement.
Google DeepMind has unveiled AlphaProteo, an AI model designed to create proteins that bind effectively to target proteins, potentially accelerating drug development and disease research. Proteins are fundamental to life, performing essential functions in our bodies, such as regulating biological processes, fighting infections, and carrying messages between cells. Many diseases occur when proteins malfunction, making the ability to design and modify proteins crucial for developing new treatments. AlphaProteo can make proteins that bind 300 to 300 times more strongly than those made by older methods. This includes binding to important proteins like VEGF-A, which is involved in various diseases from cancer to heart disease to ALS. AlphaProteo learned how to do this by studying a huge amount of information about protein structures, both from real proteins from the Protein Databank and over 100 million protein structures predicted by another Google AI system called AlphaFold. The AI model's extensive training enables it to comprehend intricate molecular interactions and generate candidate proteins that can effectively bind to specific sites on target proteins, significantly streamlining the traditionally complex process of protein design. AlphaProteo's applications extend to drug development, disease diagnosis, cellular visualization, and even agricultural advancements, such as enhancing crop resistance to pests. But AlphaProteo still faces challenges with certain complex targets, notably failing to design a binder for TNF-A, a protein associated with autoimmune diseases like rheumatoid arthritis and other inflammation-based diseases in the body. Despite its potential, AlphaProteo and AI-driven protein design faces criticism. Critics have raised concerns about potential misuse with biological agents or weapons, data privacy, and the concentration of this technology in the hands of a few large tech companies. As AlphaProteo continues to develop, careful consideration of its broader implications and robust governance frameworks will be crucial to ensure its responsible development and deployment.
That's it for today. Thanks for tuning in to Discover Daily. If you enjoyed this episode, please subscribe on your favorite podcast platform. In other Perplexity news, if you're heading back to school and use Perplexity to search the internet, ace exams, and learn fast, now you can give that edge to your classmates and score some rewards while you're at it. Until September 15th, log into Perplexity with your EDU email address to redeem a free month of Perplexity Pro, and check out the description for the exciting ways you can unlock prizes and share Perplexity with your entire campus. You'll also find more information there on the stories covered in today's episode. We'll be back here tomorrow with more stories that showcase the fascinating world of technology, science, and culture. Until then, stay curious.